on your phone, turn off the sounds on your phone. You probably bought like 14 other things attached to the Wi-Fi, which is why I'm on 3G right now. Thanks so much. You should probably turn those on silent as well. This will be video recorded. I can't say videotaped anymore, even though that's how I learned how to do things. This beard is gray. So we only have this working microphone because it's an all-volunteer event. Please donate. So during the Q&A session, you'll have to raise your hand, speak clearly without the assistance of modern technology. The speaker will repeat that for the recording for all the streaming people who just got lost and decided to stop at a Starbucks and connect to the Wi-Fi. So, question, repeats, answers, learning. Everybody ready? Oh, wow, you're not even awake yet. That coffee hasn't kicked in. Is everybody ready? Thank you. Yeah, you don't have to be excited about me. You should be excited about our first speaker, whose name got removed because somebody wants me to take an update while I am traveling. That's rude. Thorstein Limhus is a Linux kernel development follower. He's been starting since the start of the century, turns out. He's known for his kernel log column, which has, over the years, covered the features of more than 70 new Linux features in detail. His elaborate and respected article series is published by his employer, the German CT Magazines, Europe's biggest computer and tech magazine, both online and in print. If you don't know what print is, ask somebody who's got a beard like mine. He used to contribute to the Linux kernel, but has put that aside just so he can cover and come to conferences like this and talk about open source. Please give a round of applause for Thorstein Limhus.
Yeah, welcome everybody. I haven't used such a mic for quite a while, so if I don't hold it right, just let me know. Yeah, but let's go. Yeah, it's the 20th FOSDEM already, and I think when giving the keynote, that's the biggest chance to really give thanks to the organizers and all the volunteers that make these great conferences happen. So give a round of applause, please. Yeah, thanks for all this work. A warning, this talk is kind of part of the history talk, but don't worry, it won't be a history class. I promise, I make sure of that, and everything I mention is kind of relevant for today, and there will be a moral of the story at the end. So let's get started. The stage. When the first FOSDEM actually happened in 2001, shortly before that, Linux 2.4 had just been released. It basically had all the important features needed back then, kind of everything it needed to conquer the world and bring us where we are today. POSIX support, graphical interface, it was portable to various arcs, and the performance was good. Since then, a ton of improvements have been merged into the Linux kernel, and I can only mention quite a few of them, because otherwise this talk would take all day, or even 2 days maybe. And one of the things that happened, Linux was growing up. 2.4, for example, would likely not run very well on today's computers, obviously because lots of drivers would be missing, but one of the things that wouldn't work is, would be problematic would be the number of CPU cores in modern systems, because back then uniprocessors were quite the norm. If you had an SMP system with 2 processors, that was unnormal back then. But today we have CPUs with 12 or 16 cores actually, and even smartphones have 4 cores, and that might be way too much for Linux. It was actually SMP capable since June 1996 already, but back then that was kind of brute force how it was made possible. There was a big kernel lock. That's basically that only one CPU core was allowed to execute kernel code at a time. So you had 2 programs running in parallel, and both wanted to call into the kernel to make it do something, and they had to wait for the other one to finish. That actually was solved with finer grade locking that followed in 2.2 and 2.4, so the next 2 or 3 years. And that made Linux scale a lot better already. So in the 2.4 days, it wasn't that bad anymore, but other Unixes were known to scale a lot better. The Linux developers actually continued to work on that, and by 2.6, Linux had got 1,000 of finer graded locks. Yeah, but the big kernel lock was still around. Desperate, even if some people had assumed it would be gone by 2.6 already. I looked it up. Actually, 2.6.6 had about 500 big kernel lock calls back then. And as it turned out, many more steps were needed and had to be taken to get rid of the big kernel lock. So network's acting up here. If you're interested in all of those details which had to be done, you can look some of them up on LWNNet, which is a great site that reports about the happenings in the Linux kernel all the time. As you can see, between 2004 and 2011, when the big kernel lock was removed, there were lots of articles that explained what all the problems were. Yeah, and as I mentioned, Linux got rid of this big kernel lock that was a problem for scalability in 2011, so basically after about 11 years. And that was possible thanks to heroic efforts by various developers. Especially, we have to thank Arndt Bergman for that, who actually took care of the last few steps that were really a lot of work without much gain, maybe. And it was quite a gain, but it was really hard doing this last things because they were odd drivers and things like that. But scalability since then actually remains something being worked on. If you look at LWNNet again, there are many more articles over the past few years that were about scalability. And many small improvements happened over time. It's kind of a never-ending story. Like recently, there were some memory management optimizations. There was a new scheduler load balancing core that got merged into the Linux 5.5 kernel, which is the latest right now, and many other things. And most of you that are not kernel developers don't notice any of this because all those changes happen basically under the radar. But thanks to this, Linux is and stays one of the best scaling OS kernels these days. Maybe it's even the best. I was a bit careful in writing that, so I went for one of the best. Maybe I was overly careful there. Yeah, that's one of the things that happened in various small steps during this past 2 decades. And getting rid of the kernel lock was really one of the big first achievements with that small steps that happened. And that was possible because that was something everybody worked together on. It's kind of common goal, but more often there is some competition between the kernel developers. And one of the things that Linux kernel was actually still missing in the early FOSDEM days was built-in virtualization capabilities. And that's not unusual because virtualization on x86 Linux was not very popular or not famous back then. That only happened during the mid-2000s with Zen. Some of you might remember getting popular in 2005. And x86 processors actually started getting virtualization capabilities back then. Zen back then actually looked like the obvious and fitting solution for the Linux world. There was no competition there. Everybody thought that would be what will make that what everybody would be using. There was just one problem: support for running for using Zen as a host or a guest with Linux was out of tree. But a lot of people didn't care that much. And the other problem was Zen was actually kind of a kernel underneath the Linux kernel. Then suddenly, out of the blue, in October 2006, KVM came. Merged already half a year later into Linux kernel because it was quite small. It was quite small, and being compared with Zen actually didn't offer that good kind of feature set. The performance was worse. It had less features and actually required a CPU with virtualization capabilities. Sometimes it looked a bit like a toy. But in the end, it turned out it was quickly improved because various people and companies found interest in it and helped with little steps making KVM better. And as some of you might know, in the end, KVM turned out to be a game changer. Today it's basically used everywhere these days, and actually one of the cornerstones for what made Linux rule the cloud. Zen is still around. The support for running as host and guest with Linux actually got only merged 5 years later in the 2.0 days, and these days Zen is quite small when compared to KVM. So why did KVM succeed? Yeah, one of the reasons that might be a factor might be that Zen sources didn't get the code upstream fast enough, but I think the real reason is KVM had a better, more flexible and future-proof design, and actually one that allowed Linux to stay in control because it was built into Linux, not underneath it. And that's obviously suited Linux more and its developers, so they became interested in it and helped making it better. And yeah, that's how it ended, and that's why KVM rules the world these days. Yeah, that's most kind of history lesson. But on the other hand, that's things like that happen every day, every now and then these days also. For example, recently there was a DBDK. That's a technique to make network packages go straight into userland applications and bypass the Linux kernel. That obviously didn't suit the Linux kernel developers much, so they started to fight back and worked on solution, the Express Data Path and XDP, and something built upon that's called XDP socket, where userland programs can immediately get those packages, so the kernel stays in control. And it seems those two solutions actually can keep up with DBTK these days, so it's likely. I'd say if I would bet, I'd bet on these two solutions, and I think they will gain territory back from DBTK because it's better integrated in Linux. Another example is asynchronous I/O. So a program can do something else when it reads or writes, makes the kernel read or write data from some storage device. That's normal in the Windows world, but unusual in the Linux, except for maybe great big databases. But these days, a solution finally shows up that's called I/O U-ring. It was merged into the kernel a bit more than 1 year ago, and it's an answer to a similar bypass technique that's called SPDK. And yeah, and it actually will help getting the performance out of these new SSDs because they are really quite fast, and to get the performance out of this, such an asynchronous I/O solution is needed because the syscall overhead is way too much otherwise. And the thing is, just as KVM, both these solutions got imported into the Linux kernel and started quite small, and then got improved in small steps by various people that found them interesting. And it shows that things like that happen all the time. Virtualization was not the only thing, the only solution to make Linux a host for something. There was something else that Linux missed during the early FOSDEM days. There was support for containers. And that's actually quite interesting because other Unixes back then supported them already. FreeBSD, for example, did, and Solaris learned it a little bit later. For Linux, it only became famous in 2014. And a lot of people sometimes wonder why did it take so long? Yeah, it took so long basically because the kernel lacked features to build something similar with Linux. And yeah, those features had to be built, but that happened one step at a time. It took years. Some of these features actually we use today for containers were actually built for containers and Docker, that like the various namespaces. Some of those features we use for containers are actually not directly partly built for container use, like the C group stuff, the control group stuff that makes sure one process can't take all the CPU or memory and other stuff. And that in the beginning actually was used a lot with virtualization with KVM. And some of the features we use to build containers these days actually were built for totally different use cases like capabilities and seccomp and a few other things. And the thing that made Docker popular in the end was actually Docker combined these and a few other features in a new and more attractive way, and that made Linux containers suddenly quite popular. And in the end, kind of changed the world. Funny detail there. LXC was designed to become the preferred solution. That's a bit older. And there were actually two other Linux container solutions, Virtuoso and OpenVSS, that became quite small thanks to all the other things Docker brought. And Linux vServer is the other solution that is basically forgotten these days. They came earlier and used out-of-tree patches, but thanks to the kernel and its small steps and its features you can combine in interesting ways, Docker overran them basically and is now the leading thing. LXC actually is still around, definitely not as big as Docker. And the funny detail there is, just imagine if it would have been one company that would have invested all the money in making the kernel capable of running containers and building an LXC as a userland process on top of it. That actually might have been a pretty bad return of investment for them, because yeah, other companies can use those features you built as well. Yeah. And that really makes it a little bit risky for companies to invest that much money, but on the other hand, that's a problem for the kernel. Linux, the operating system, actually got a way better and more flexible solution thanks to this, and thanks to all the various small steps that were taken, and what are the reason why we have so many small features that Docker could combine in a new and more attractive way. Docker already was a quite unexpected but welcome surprise. That's not the only time Linux kernel stuff and kernel features show up that's nobody really aimed for. And one of those things actually is changing the kernel these days. And Linux basically is on a trip into the unknown right now. What I'm talking about is an improved Berkeley package filter. That's called BBPF for short, or these days CBPF or classic BBPF. The improvements began in 2014-15. That's an in-kernel mini VM, a mini virtual machine, but not like a virtual machine that emulates a different computer, more like a Java VM where you can upload programs to, and then the kernel executes them. That's something for 20 years ago TCP dump, for example, relied on to only get those packages from the kernel into userland and into TCP dump the user was actually interested in. That's needed because for performance reason, because copying everything over simply is so much work. It will slow everything way too much down. This improved CBPF actually got called eBPF. You might have heard of this thing. Some people even call it just BBPF for short these days. I'm kind of angry with the developers there, because now we have an old BPF that's called BPF and a new BPF, and nobody knows what somebody's talking about. Yeah, that's really sometimes annoying, but most of the time if you read BBPF these days, it's actually the enhanced one that's meant. Yeah, it became a really fast and much more powerful VM to run programs in kernel mode. That's actually, if you had suggested something like that to Linux Torvalds 20 years ago, I guess the idea would immediately have been shut down, because it's kind of crazy, but these days it worked. And one of the reasons why it's worked is actually it got improved as a small thing, and then improved and improved again. And that way everybody could be sure that's not dangerous or something. The network developers actually built this eBPF to scratch some itches they had, and improved it and improved it again. This XDP stuff I mentioned earlier is actually built upon it and really relies on it. But these days other kernel subsystems started to use it as well, or will soon. And more seem to be interesting. Actually, on LWNnet, it became kind of a running gag that during the articles, there's often the case where some solution is sought for a complicated problem, and then often BBPF is suggested to use it. It won't be used all the time, but it seems it's getting into the kernel at various areas. And yeah, eBPF is still not done. I mean, it's got developed over the past few years, but it's improved more and more and starts to change the kernel fundamentally, and makes Linux actually get more aspects of a microkernel. This thing, what some of you might remember, this big debate if microkernels is a better design than the stuff that the model that Linux currently uses, which is more like a monolithic kernel. But as I said, Linux gains more aspects of a microkernel, and that's actually what Europe's biggest computer magazine wrote, the German CT magazine. It looks like that. And if some of you now see people giggle next to you, that's because, yeah, because I wrote that. Yeah. Maybe I should try that on Wikipedia, write something somewhere and then change and give myself a source. Yeah. But I'm not only popular for this kernel reporting. I do that for 15 years now. I'm also did a few things in my spare time for kernel regression tracking, and I was actually invited for the kernel summit, so I know what I'm talking about. And I'm not the only one that actually wrote this microkernel comparison. LWNnet actually mentioned it as well. And there's another running joke. Yeah, you laugh, but this is one of the core developers that made a lot of things happening we all use every day. Sooner, we laugh these days, but maybe it will happen. Maybe we stand here in 10 years and say, yeah, that's how it all began. And there's also another improvement that's coming where the microkernel aspect was mentioned. That's really fascinating to watch. It remains to be seen what comes out of it. Maybe we're at the beginning or already in the middle of a small revolution that makes Linux more error resistant, flexible, and more powerful. It remains to be seen. Thing is, most people actually don't notice because it's happening in a lot of small steps and without disrupting old features. So that can be, you don't have to care if you're not interested in that. Yeah, long-standing wishes. That's a different topic. Another area where Linux actually was behind in the early FOSDEM days was a proper tracing solution to look into the system or a specific program, to look why the system is slow or why the program is slow. And the famous solution in this area is actually dtrace, actually published in 2005 and built into Solaris. And people for years wanted something similar with Linux. And they got something recently that's called BBPF Compiler Collection, BCC for short, and BBPF Trace. And those are actually called dtrace 2.0 these days by Brandon Gregg, which is one of the leading experts on dtrace, at least according to Wikipedia. And no, I didn't write that there. Yeah, and actually those two new solutions the 2.0 is appropriate because BBPF trace and BCC actually can do more than the old BCC, more than dtrace. It's pretty cool. If you want to know more about it, look at Brandon's website. I mentioned it here. And he also published a book recently that's quite cool and gives a lot of details into what you can do with modern kernels and tracing them. And yeah, it took basically like 10 or 15 years to get everything into the kernel. And the funny thing is that actually happened without a design that had something like BCC or BBPF trace in mind. They emerged thanks to evolution, because the kernel developers actually built various building blocks over the past 10 or 15 years, sometimes with smaller or different goals. You have the tools like ftrace, tracepoints, perf, kprobes, and all those things. And then those were one part of the solution. The other part is eBPF. There it is again. And yeah, then somebody combined those tools and made new things possible. And then actually BCC and BPF trace came out by some people. And ta-ta, yeah, that's how we have dtrace 2.0 these days. Really great how things work out, and without a design like you would have normally when you're building an operating system. Yeah, something impossible. Linux will soon offer a really great and important new feature, one almost nobody would have expected during the early FOSDEM days. It will be real-time capable. So it will be able to use Linux for your laser cutter or for your roboter in your industry line that manufactures cars or whatever, because Linux can make sure that the program that's controlling your laser cutter is always called in time to react to certain events. And that's really important for this use case. Yeah. Back during the early FOSDEM days, that was actually nothing people talked about yet, but it was an idea actually in some people's minds already. Especially in the mind of Thomas Gleixner, who's one of the leading developer for the real-time kernel patches. And he actually recently, last fall, on the Linux Plumbers conference, gave a great talk about this. The URL is here. I also, you don't have to write this down. I will upload the slides to the website. I tried to do that before, right before the talk, but the network was overloaded, so you have to wait for that. Sorry. But it's a great talk where he's looking back and mentions a few nightmares all this RT development gave him. And one part of this talk is actually, he mentioned a few quotes like real-time people are crazy and not going ever to get merged into the Linux kernel and things like that. And for I know I spoiled the talk a little bit, yeah, but these quotes actually are all from Linus Torvalds himself. It was most of them were from 2005, from a great, or 2004, a great debate of if making real-time Linux real-time capable actually is a good idea. Yeah, but the developers actually didn't give up. They basically started working on it, having this external patch set, and got small steps, small patches, and into the mainline kernel. And yeah, that actually made Linux better for all of us, even if we don't use real-time systems or don't need them. The real-time patches hit quite a lot of problems and scalability issues first. And that in the end, they fixed them, and that in the end made Linux better for all of us. And yeah, the thing is, RT developers actually had a lot of body blows. And one of the worst was basically like 5 or 6 years ago. They had basically like 90 to 90% of the route done that were needed to make Linux real-time capable, but they basically needed money for the last mile, or the last 5 years, as it turned out. Yeah. And the thing is, that was needed because lots of companies that used the RT patches back then actually didn't help much with development. And but luckily, the RT people were successful. They came to the Linux Foundation and talked to them, and they actually founded a project with a few companies in 2015. And yeah, thanks to this project, the main trip will soon be finished, because the real-time capabilities are the most important patch actually is in the Linux kernel already, the config option to enable the real-time support. It's not exposed yet because there are few things missing. The biggest thing is actually a rework for the print K stuff. That's actually what's doing your logging, which you can see with dmessage. But that's in the work, and there were some disagreements, but they were settled really recently. And the patch was, the new patch to make everything happen was sent to the Linux kernel mailing list for review recently. So it's likely this will get into the kernel this year and then make Linux real-time capable. Describing all the steps the real-time developers had to take would take also a day or two maybe, because if you go to LWN and actually look what problems were discussed over those years, you have many articles you can read. But it shows even crazy goals that look unreachable can be achieved in small steps. And yeah, the thing is, that's actually how most of the Linux kernel features evolve, as they are often not designed by some company or some in a meeting or something. Often it are simply individuals that want to realize an idea or a dream and make Linux do something. And sometimes they even abused companies to realize their ideas. That happens. They simply look for companies that might be willing to pay them. And some of the developers sometimes have to find other places to find money. But it shows really with a good idea and commitment, and even big and crazy dreams can be realized. Real-time patches actually are a really good example for that. Yeah, I mentioned a few times that Linux is working, the Linux kernel is working differently a little bit. And nevertheless, it learned a lot of things since the early FOSDEM days, but it took them quite long to to get those features realized. But that's just how the Linux world is, because you simply can't just hire 50 developers, make them work for 2 or 3 years to build a specific feature, like Sun, for example, could do with zones, D-trees, or ZFS. Because if you do that, there's really the risk that after 2 or 3 years you get to the kernel developers and they say, no, we don't want that, that's way too big and you're doing this and this wrong. And because they want to see these small incremental steps, because that work quite great for the Linux kernel. And that actually means more work for the companies if you want to realize something. Yeah, it served the kernel developers really well. Often lead to the best solution on the market, but it has disadvantages too. So now I'm going to check who's awake. Who's hands up and leave it open. Leave it up if you're awake. Yeah. So leave it up if you agree with standing here. Is ZFS actually the most sophisticated file system in the Unix world? Yeah. Quite a few hands went down, but about, not really 50%, but close. But some people think it is. But ZFS and the Linux file system is actually one of those areas where a lot of people say Linux is still not the best kernel for that, because ZFS is better. And the funny thing is, there were work on ZFS for Linux actually was started in 2008. It's called ButterFS. I guess most of you have heard about this, but as most of you will likely know, it hasn't reached that goal yet, and it doesn't look like it will be anytime soon. If you go to Wikipedia, you actually see a few features that are called unstable, and a few features that were announced or that ZFS already had that are not even implemented yet. So the big question is, what took them so long? Yeah, one thing for sure, it was overhyped. Just like all the other features, ButterFS was merged into the kernel when it was still quite small, and then improved in various little small steps. Yeah, and that take a lot of time, as I showed with the other examples I gave earlier. And it also shows how quick things improve in complicated areas. Mainly depends on how complex the area is, the problem actually is you will try to solve, and how many individuals or companies back the development. And it turned out the problem scope here is really, really complex, and a lot of companies didn't care too much. Some companies actually helped, like Oracle, SUSE, Facebook, and a few others, but some don't care much and didn't help. No complaint, that's how things sometimes are in the Linux world. So the big question is, will Linux get something to compete with ZFS? I'm pretty sure sooner or later it will. The examples I gave really show that. It might just take 10 more years, maybe just 5, but maybe 15, who knows? We will see. Just to mention a few recent events, there was this file system Bcachefs that a lot of people have high expectations there. I'd say wait and see and keep your expectations under control to not create another hype, because history shows it's a hard problem. The history of ButterFS actually shows it's a hard problem that takes a lot of effort. And Bcachefs right now is basically a one-man show and not even submitted to mainline inclusion yet. So it's unlikely to fly soon. Even if it got merged, companies would need to have a lot of testing and testing in the field before it really becomes stable. So that will take a while if things really develop in this direction. Maybe in the end it turns out that ButterFS gets improved and that becomes the ZFS for Linux in the end, just as planned. Nobody knows that. Yeah, I talked a lot about the features already, but let's switch gears a little bit and talk about Linux kernel development, how the kernel is developed itself. Because during the early FOSDEM days, the Linux kernel development looked really odd to outsiders. There was no central development forge like SourceForge, GitLab, or GitHub. Development was actually totally driven by email. There were dozens of mailing lists, no tracker for patch submissions, no central issue tracker, neither for developers nor users. There were long, unstable development phases. There were so new features that got built and integrated into an unstable series, sit there long and reached users only after 2 or 3 years. That made a lot of people unhappy. There was no predictable release cadence, no driver database where you could look up if your hardware is supported and how good. And actually, we had an overworked lead developer. Because we didn't, one of the reasons why he was kind of overworked, we didn't even have a version control system back then. For the younger ones in this round, yes, 20 years ago we had version control systems already. Most people, most projects actually used them. For the older ones, yes, those were ZVS and SVN, and maybe those were the Middle Ages back then, I don't know. But Git really made things a lot better, yeah. But then back to kernel development. There were way more odd aspects for kernel development, and the approach actually improved quite somewhat since then. Like we have Gits since 2005, and that changed the world really to the better. Thanks, Linus. It's the second project that quite made the world change. And now I have here strange pop-ups here that's blocking my site. Yeah. We actually got a predictable release cadence, release cycle. Since 2005, we basically get new releases from the Linux kernel every 9 or 10 weeks, so it doesn't take that long to get a feature out to the users. And this approach where every new version brings new features actually was called crazy by a lot of people when the Linux kernel switched to it, but it turned out very well, and actually browsers actually later picked it up. So Firefox and Chrome, we all are used to this model that basically where the Linux kernel built the path to actually do that. We also got stable and long-term kernels that are supported for longer, like the latest, a lot of those long-term kernels are supported for 6 years these days. But to be honest, many of the odd things I mentioned a few minutes ago are still around, and some even got worse. So these days we don't have dozens of mailing lists, we have hundreds of mailing lists, and development is actually still driven by email. There is a Bugzilla, but the thing is, where you can report issues, but the thing is lots of developers don't look there, because in most cases it's not the official way to report bugs. Just a hint for those that want to report bugs to the kernel developers, the proper place, and most of the time, is a mailing list. Security also became much more important since then, but still we have no automatic code checking in a central place. Most of the subsystem maintainers use something, and some of the developers also, but nothing central here. A lot of room for improvements here, and on some of those things actually someone is working on them already. There's always the idea, why not switch to a central forge like GitHub and GitHub for development, because you would get a lot of things for free then. But no, that won't happen anytime soon, because just like with features, the developers demand that things are improved in small steps here too, because yeah, that's how it works well for them. Yeah, but that really needs someone that's motivated enough to do that without an immediately return of investment, and that makes it sometimes a little bit hard. And yeah, that's why some of those things are still kind of archaic with Linux kernel development. It becomes more and more of a problem. There was also recently on a Plumbers conference in fall talk about it with what problems a lot of developers have to deal with these days. Thanks to that, workflow group was actually started and already got to work. So a few improvements are coming. There's now a Garrett instance which developers can use to submit patches to the Linux kernel. Remains to be seen how many kernel developers will start to use this and how if they liked it. But as you can see, development is improved with small steps, just like with features. And yeah, that will take some time. Sometimes people ask, why can't the Linux Foundation help here more? Maybe it should help a little bit more, but I'm not sure how much, because the Linux development model really worked well, and I don't think it would be a good idea to basically organize them like OpenStack or Kubernetes are developed with lots of committees and hierarchy and things like that. Yeah, that might not be the best for the Linux kernel. Nevertheless, Linux kernel development, meanwhile, runs at the usual pace. We get new kernel versions every 9 or 10 weeks for many years now. If you're interested in a few numbers, we are actually each of those versions brings about 13,500 commits. Sometimes it's 1,000 or 2,000 more or less. And all of those bring about 300,000 new lines every version. So about, every year the kernel grows about 1.5 million lines per year. And that actually happens about 15 years after Andrew Morton, who was back then number 2 in the hierarchy, wrote this. And famous last words, but the actual patch volume has to drop off one day. As I said, that was 15 years ago. It didn't. Back then, we had like, I think, 6,000 or 8,000 patch commits every kernel release. As I said, these days we often have 13,500. And the later number is actually stable these days. So the patch volume is quite constant there. Yeah, but that was not the only thing Andrew Morton wrote back then. He also said we have to finish this thing one day. Yeah. I don't think that will ever happen. I guess Linux might be forgotten maybe in 100 years, and because all developers might work on something else, or we still use it in 100 years, who knows, remains to be seen. So, now I'm coming to the end slowly, summing things up. Now, the Linux developers really solve big problems in small steps. The big kernel log showed that. These small steps lead really to better and more flexible solutions like KVM did. Sometimes these small steps actually make groundbreaking new technologies possible like Docker did. These small building blocks that are built in these small steps actually sometimes can even help fulfilling old wishes like dtrace 2.0 did for the wish for a tracing solution. And this process actually can lead to quite unexpected disrupting results. Like this BBPF thing I mentioned, really keep an eye on it. It's going to be fun what's coming out of that. But thing is, that's what made and makes Linux so great, because those were just the big examples during the past 2 decades, the big features that were developed like that. It's basically all the other stuff was quite similar. But it shows it's what makes Linux so great, and reaching big, and shows that you can reach big goals with small steps, and even if that takes time. Yeah, and if something takes time, it obviously also needs money, because we all have to eat in the end of the day. And yeah, so to realize them, it often needs someone that's really committed. Ideally, someone that's an individual that wants to realize a dream and has a dream about a new feature, and that and drives, makes everything happen to realize that in the kernel, because that's how all those features I mentioned got developed, and the real-time stuff I mentioned was a really big and crazy dream, but even that got realized this way. Nevertheless, in some areas we are still not there yet. To improve things, you have to basically become an individual that is committed and find money to get this dream realized, and then maybe Linux will get a file system that's as good or even better than ZFS, and we might get developer tools and schemes that are even better than what we have these days, just like Git was, for example, or other things that will have a positive impact on the world, or the world of free and open source software, like Linux and Git had and have, which, just as everything else I mentioned, were just a dream in somebody's head that somebody realized, in this case, Linux. That's it. And that's, if you're wondering, slide 234. All those slides. I have so many things to say, and so many things in my head. That's why I'm using these slides to keep on track. So, are there any questions? We now have to switch mics.
All right. If you're okay, if you're planning to leave, this makes questions a little bit difficult. We have about 5 minutes left for questions. If someone has a question, I now can't get to you because. All right. If folks leaving the room could leave the room as quietly as possible so we can hear the intelligent discourse from the questions in the audience.
Thank you for your talk. What is the dev community's position on improving the kernel to make use of quantum computers and quantum chips that are coming up? Quantum chips? Can somebody repeat?
On quantum computers?
Yes, thank you.
I have no idea. I don't think anybody is working on making Linux run on quantum computers. Maybe we need new operating systems for them. Remains to be seen. Maybe somewhere in some lab somebody ported Linux there, but I have no idea.
By the way, if you're exiting the room, could you please do it from the middle or the back? They're still trying to actually answer questions at the front of the room at the moment.
Thank you for the talk. I wanted to know, do you think that Linux has gotten faster or less fast during the 20 years span?
Sorry, I don't understand you. It's too loud. Could you maybe come here? Oh yeah. Oh yeah. Thanks. Yes. Now again.
Do you think that the Linux kernel has gotten faster during the years because, as software grows, it's sometimes slower? There was many performance enhancements. So do you think it has gotten slower or faster on the same hardware? Or
You mean if it should be how it could be faster or what?
during all the time that passed, you talked about, do you think that the kernel has gotten faster?
It's too loud here. Sorry, I can't understand it.
Okay, we're going to try this again. Does anybody have a question? That hopefully isn't all the way up there.
Oh,
All right, well, we'll just keep it.
did you ask if the Linux kernel was growing fat or what?
I have a small question, and the question is whether Linux gets faster with these updates.
If even faster release updates?
With all the improvements, whether the Linux gets faster.
When Linux gets faster with all the improvements, Linux basically gets faster, basically with every new version, always in little steps also. But is it too slow in some areas, or where do you think it's too slow? It's.
I think the point was with the increased code base, it might get slower over time.
Can you repeat it?
With the increased code base over time, it might get slower because you have too many lines of code.
You mean because it's getting slower because it's so big?
No, not necessarily right now, but can it be in the future?
Yeah, the Linux kernel is quite modular, so you can build everything into it what you want. But sure, some of those features have some overhead that make Linux maybe slower. And that's actually likely would become, this overhead would be a problem if you would use a modern Linux on a quite old system. But on the other hand, you can configure Linux quite modular. And I mean, it's used on a lot of embedded systems. So it shows it can be made quite small and at the same time also work on quite big servers with hundreds of CPUs. Yeah.
Right. This is our last question.
Last question, okay.
My name is Oleg. Sorry, I speak a little bit English. I would like to ask you about, if I understand you right, you said that each year we got 1.5 million lines more. Just your opinion, what's happened in 10 years?
What's
who tested it? Who tested it?
I can't hear it, so the speakers are away from here.
Could you explain me how it's possible to test it at all?
How to test
I think
all,
that
yeah.
Intel doesn't care about commit from IBM or Facebook or another companies, yes?
Yeah,
Who tested at all?
No, I guess nobody tests it all because you can build it in lots of different ways.
That's why we have a lot of issues.
What?
That's why we have a lot of issues.
It's a lot of people try testing the Linux kernels throughoutly, but you can't test it all. And that's also something that really needs to get better, which the workflow group also, I think, has on its roadmap to make sure the kernel testing gets better. Yeah. Okay, I think we are ending this. If you want to give any feedback, just talk to me, even if you didn't like it. Yeah, and if you want to follow me, you can follow me here if you want. Thanks again, and have a great FOSDEM.